Assalamu alaikum. Kirchhoff's second law, or Loop's law, states that the sum of the electromotive forces is equal to the sum of the potential differences around any closed loop in a circuit. What do we mean by closed loop? Any possible path for the current. In simple, we can say sigma EMF equals sigma of potential difference, or sigma epsilon equal sigma V. In case of series circuit, we have one possible loop. So this is a series circuit. Here we can take the path of the current. Because it's one current, we can say it's clockwise or anti-clockwise. So if we take this loop, we say the loop is A, B, C, D, A. This is a series connection of the circuit. So it's one current pass through the resistor, and from the resistor to ammeter, and from resistor to ammeter, and so on. So this is one current. You can see here it is the same value of the current. But in parallel circuit like this, we have many loops. This is a cell denoted by E1. This is a positive and this is a negative. We can suppose that the current is I1. The current starts at junction and ends at another junction. So starts at B, so this is I1, and end at A, this is I1. We have, this is a loop. We can say this is loop number 1. Another loop, this is another cell E2. So we have a current denoted by I2. Starts at junction B, so this is I2. And end at junction A, I2. Because Kirchhoff's first law, at junction A or junction B, the sum of currents in equals the sum of currents out. I1 is in and I2 is in. So the current through AB must be out. So the current I3 take this way. So this is loop 2. So in any loop, the sum of EMF equals the sum of potential difference. Let us talk about EMF and the potential difference as energy transferred per unit charge. We know that the EMF is the energy transferred per unit charge. So the energy equals Q times E. And also the potential difference is the energy transferred per unit charge. The energy transferred per unit charge. The first one is the energy transferred from chemical to electrical per unit charge. This is EMF inside the source or battery. But V is the potential difference. It is the energy transferred from electrical to any other forms per unit charge. So from this equation, we can say W equals Q times V, because the circuit contains a source of energy, which is the cell or battery, and source of consumer of energy, which is the resistor. So we can say the sum of energy in equals the sum of energy out. So the sum of energy in equals the sum of energy out. If we talk about unit charge, we cancel Q with Q. So the sum of energy in, or the sum of EMF, equals the sum of potential difference. Kirchhoff's second law is a consequence, نتيجة, of the principle of conservation of energy. If a charge of 1 coulomb moves around a circuit, so this is 1 coulomb, moves around this circuit. So this 1 coulomb gains energy as it moves through each source. So when this 1 coulomb moves through this source, it will be gain energy and loses energy as it passes through the potential difference. So loses energy. So this is IR. So the gain, the total energy transferred to the charge carriers from the cell or the battery equal the total energy transferred from the charge carrier to the resistor. The source of energy is the cell, remember, and the consumer of energy is the resistor. So the energy gained equal the energy lost. So in any circuit, the energy is conserved. So this law, Kirchhoff's second law, is law of conservation of energy. The energy is conserved in Kirchhoff's second law. Now, loop. This is loop's law. So the direction of loop is very important. How can we solve any question? Look please at this. This is a cell. Contains positive and negative. The positive represents the higher potential and the negative represents the lower potential. Now, if the charge carriers move from lower potential to a higher energy, a higher potential, gain energy. So it will be positive electromotive. Look at this example. This is a resistor R and the cell. Let the current in that direction. So this is the case number 1. The current to the right. Because the current to the right, the point A has higher potential than the point B. So if that is the loop direction is to the right, and the current is to the right, so what will happen to that charge? Loses energy. So this one is negative IR. So lose energy. What about the cell? Because the charge goes from lower potential to higher energy, it will be gain energy. So this positive electromotive force. Remember, this is the direction of the loop. It is to the right. It is the same direction of current in that loop. Look at the second case. The current go to the right. So the point A has higher potential than the point B. Point B has lower potential. And this is the current pass from A to B. So we lose energy here. So it's a negative IR. But because the loop direction is opposite in physics means negative in physics means opposite. So because the direction of the loop is opposite to the direction of the current, we say it's a negative IR. It becomes a positive IR. So the potential difference around the resistor in the second case is positive IR. What about the electromotive force? The movement of charge carriers, it's from lower potential to higher potential. But because this is the direction of the loop, we say the electromotive force is negative. Now, don't confuse. I give you a general way. Generally, in case of resistor, if the direction here, it's negative IR. Negative IR generally. If the current pass from A to B or from B to A. But in case of the cell, I advise you to put the direction of charge carrier. It's from lower voltage to the higher. So this is the direction of charge carrier. If the loop has the same direction as a charge carrier, so the electromotive force will be positive. If the loop has opposite direction to the charge carrier, it will be negative electromotive force. So when you solve the question, starting to put the direction of charge carriers. Let we see this example. He said, in the circuit below, shows 3 currents flowing in it. Find out I1 and I2 if I3 equal 3 ampere. First step, put the direction of a charge carrier. It's from lower to higher. So this is the direction of a charge carrier. Here, from lower to higher. This is the direction of charge carrier. Second, look at the direction of the current in each loop. I1, starting at junction. This is junction A and this is junction B. So any current start at junction and end at junction. So I1 start at A, so this is I1, so this is I1, end at B. I3 starts at B, and end at A. I2 starts at A, this is I2, and end at B. Second, here we have 2 unknowns. So we need 2 equations to solve to get the 2 unknowns. You can choose loop 1 and loop 2 and solve each one or solve them simultaneously, or you can apply Kirchhoff first law because it's easier, and then choose one loop. That way is easier. So I say here, at junction A. So at junction A, I apply Kirchhoff first law. Remember, Kirchhoff first law, the sum of currents in equals the sum of currents out. Current in at junction A is I3. So I3. The currents out, I1 and I2. So we say I3 equals I1 plus I2. The value of I3 is given 3 ampere. So we say I1 plus I2 equals 3. This equation number 1. And then we take one loop 1 or loop 2. The same answer. So I choose loop 1. Loop 1, it means the Kirchhoff's second law. When you choose loop, start at point and end at that point. I start at this and I go in this direction because this is the direction of the loop. So this is the direction of the loop. It is the same as the direction of a charge carrier. So 6 volt is positive. Now, the current here is I1 and the resistor is 3, and this is the direction of the loop, so it's a negative 3. The resistor is negative 3 I1. Now end at B. Now we go to this path. Now this is the direction of the loop. It is the same as the direction of charge carrier, so 3 volt is positive, so plus 3. And now the current is I3 and this is the direction of the loop, so we lose energy, so it's a negative 2 I3, and then we'll be out and then we reach to the same point. So this is the end of the loop. The end of the loop, it means this equal to 0. Now we replace I3 by 3, so 6 minus 3 I1 plus 3 minus 2 multiply I3, it's a given 3, equals 0. Remember, the sum of EMF equals the sum of potential difference. It means if we add them algebraically, it will be equal to 0. Now, we use the calculator or we can solve mentally. 2 times 3 equals 6. This is negative 6 and positive 6 cancel to each other. So we have negative 3 I1 plus 3 equal to 0. Shift 3 to the other side. So negative 3 I1 equals negative 3. Divide by negative 3 both sides. So I1 equals 1 ampere. Substitute in equation 1 to get I2. So I1 equals 1 ampere plus I2 equals 3. Shift 1 to the other side. So I2 equals 3 minus 1, it's 2 ampere. Okay? Now, we talk about very important application of Kirchhoff's second law. How can we derive the formula for resistors in series by using Kirchhoff's law? So this is the question. Derive using Kirchhoff's laws the formula for the combined it means the total resistance or the effective resistance of two or more resistors in series. Now we have here resistors. This is R1 and this is R2 and this is R3 connected in series. This is a positive and this is a negative. Because it is series connection, so the current is the same. So we have one current in that circuit. Now we apply Kirchhoff's second law. So from Kirchhoff's second law, the sum of EMF equals the sum of potential difference. The sum of EMF, it means the voltage in. This is the voltage in. Equals the sum of potential difference means the voltage out. So it's V1 plus V2 plus V3. Remember Ohm's law. V equals I times R, so V equals IR. V in, it is I total multiply R total. Because it is the same current, we don't need to write I total because it is the same current in the whole circuit, also inside the pattern. Equals V1, it's I multiply R1. V2, it's I R2. V3, it's I R3. I the same, so we can cancel I with I with I with I. Then we can deduce the formula for resistors in series, which is R total equals R1 plus R2 plus R3. So this is the formula for resistors in series by using Kirchhoff's second law. That are three resistors connected in series. Now we need to get the total resistance or the effective resistance. That are three resistors. R1 equals 10.2 ohm, R2 equals 14 ohm, R3 equals 23.2 ohm. Now we need to measure the total resistance by using a calculation. R total by using calculation it's 47.4 ohms. Now we use the multimeter to get the total resistance. So by using the multimeter, it is 46 ohms. So approximately the same, 46 ohms. This is by measuring. The figure shows a network of resistors connected in a battery of EMF 6 volt. But I show that the resistance of the network, it means the effective resistance or the total resistance of resistors is 40 ohm. Now we need to solve part 1. Now, resistors here in this part, they are connected in series. So we add them up. 40 plus 20 equals 60 ohm. And that resistors, 60 and 40, they are in parallel. So we write the total resistance of 60 and 40 because they are two resistors in parallel. So we write the answer is R1 times R2 over R1 plus R2. It means 60 multiply 40 divided by 60 plus 40. The answer is 24 ohms. So we can replace the two resistors as 24 ohm. Now we have here 96 and the 24, we add them up because they are in series. So plus 96, they are 120 ohm. Now we have a resistor 60 ohm and 120 ohm, they are connected in parallel. So R total, by the way, How can you differentiate between parallel and series? Series, one current. Parallel, different path of currents, different currents. So 60 and 40 parallel. And also that 160 and 120, they are parallel because we have different paths of the current. So R total equals 60 multiply 120. We use R1 times R2 over R1 plus R2 over 60 plus 120. We use the calculator. The answer is 40 ohm. So we finish part I. The second part, he said calculate the current in 60 ohm. So we need the current in that, the current in 60 ohm. This is the total current, I, from the battery. That current distributed into here, we can say this is I1. And in that branch, it's I2. And then that I2 split into I3 and I4. We need the current through this resistor. First of all, we calculate the current I2 in the whole branch. How? Because that is a parallel combination, so this 6 volt is the voltage around this, so this is 6 volt here, and also the voltage around this branch is 6 volt. So in that branch, we have here 120 ohm and 6 volt. From this, we can get the current I2. So by using Ohm's law, V equals I times R. So I2 here equals V over R. V equals 6 and R 120. 6 divided by 120 equals 0.05 ampere. But we need V2, the voltage around 96. How can we get V2? V2 equals I2 multiply R2. I2 it is 0.05 multiply R2 96. So this multiplied by 96. It's 4.8 volt. So V2 is 4.8 volt. So the voltage through 60 and 40. So the voltage of 60 and 40 ohm equal the total voltage which is 6 volt minus 6 volt minus 4.8. So 6 minus the answer. It's 1.2 volt. So the voltage through 60 and 40 is 1.2 because they are parallel. So we can get now I. Current equals the voltage through 60 ohm, which is 1.2, divided by the resistance, which is 60. So 1.2 divided by 60, so the answer is 0.02 ampere. Note that 60 ohm is greater than 40 ohm. So the current through 60 ohm is less than the current through 40 ohm. The total current, which I2, remember, it is here 0.05. One of them goes to 60, it will be less, 0.02 ampere. And the rest will be 0.03 ampere goes through 40 ohm. Because if the resistor is less, the current is more. If the resistor is more, the current will be less. So I hope you understand this lesson. Thank you.